Hello and welcome to Crash Course AP Physics 1. This is Unit 3, Work, Power and Energy. So the first topic that we are going to start is work. Work done by a constant force. For a work to be done in scientific sense, a force must be exerted and there must be a displacement in the direction of force. Work is equal to force into displacement, but this force should be in direction of displacement, means S, and this is a dot product. Work is the dot product of force into displacement. Let's understand from this example, like when you are pushing a car, so this is the force direction and this is the displacement. So at time is equal to 0, this is the point where you started, and at time is equal to t, you reached at this point. So this is the displacement, this is the S displacement in this direction, in this positive X direction, and force is also applying in the same direction. So that's why work in this case is equal to F into S. Let's see another example. A girl is pulling the trolley bag and the direction of the force is in this direction and the displacement is happening in this positive X direction. And the force is somewhat at an angle theta with respect to the positive X direction. So I can do two components of this force. So force is acting in this direction and the displacement is in the positive X direction. So now I can divide this force in two components. In X component, which is F cos theta, if this angle is theta, and this is F sin theta, right? So as from the definition of work, that the force should be acted in direction of displacement, then we calculate the work with help of that force. So work in this case would be equal to Fs cos theta, because this F cos theta is in the direction of displacement. That's why we define work as work is equal to F cos theta into S. If the displacement and the force have 0 angle, theta is equal to 0, then in case the work is equal to Fs, because cos 0 is 1. If displacement and force are acting at 90 degree, so if theta is 90 degree, then cos 90 degree is equal to 0. Then in this case the work is equal to 0. If the displacement and the force is having 180 degree angle, then the work in this case is negative, because cos 180 degree is minus 1. The unit of work is Newton meter or joule. Let's see through this some of the example. If the man is standing and the displacement is 0, then in this case the work is 0, because work is equal to F d cos theta. So the d is 0, the work is 0. If the man is holding this briefcase and the force is acting in the y direction and the displacement is happening x direction, the angle between them is 90 degree, then in this case theta is 90 and the value of cos 90 is 0. So that's why the work is 0 in this case. A man is lifting the weight and the force he is applying is in the y direction and the displacement is happening in minus y direction. So the angle between force and displacement is 180 degree in this case. So the value of cos theta or cos 180 degree is minus 1. Then we can write work in this case is Fs minus of it. Let's solve some of the example. Consider a drop of rainwater having mass 1 gram falling from the height of 1 kilometer hits the ground with the speed of 50 meter per second. G is the constant with 10 meter per second square. The work done by the gravitational force and the resistive force of the air. So here is a drop, a water drop. It is having the mass of 1 gram. It is started with initial velocity as 0 and the final velocity when it hits the ground, its velocity is 50 meter per second, and the distance it traveled is equal to 1 kilometer. In the first part, we have to find the work done by the gravitational field. So work is equal to force into displacement. This force is mg force acting in the downward direction, and this is the gravitational force is equal to mg, and the displacement is in the same direction. So work is equal to F as cos theta. So I can write force as mg, displacement as 1 kilometer, and cos theta, the angle between them is 0 or cos 0 degree. So it would be this value, cos 0 is 1. Mg as 1 upon 1000 kg, g as 10, and 1 kilometer as 1000 meter. And when you solve it, it would be 10 joule. So the work done by gravitational field is 10 joule. In the second part, it is asking the work done by the resistive force. So work done by resistive force. This is a drop, okay, and the mg force is acting downwards, and the air resistance is acting, this Fr must be acting in the opposite direction, in the positive y direction, but the drop is going downward, means there is a net force acting in the downward direction, this net force, and this net force is equal to mass into acceleration. So I can write the equation as mg minus Fr is equal to m into a. So to find this acceleration, we have to use third equation of motion, which is v square is equal to u square plus 2as. V as 50 square, u as 0, 2a we have to find, and the displacement in this case is 1 kilometer, which is 1000 meter. And when you solve it, you get a as 5 upon 4. Let's substitute this value in this equation. In this equation, so mg, mass is 1 upon 1000, g is 10, Fr we have to find is equal to mass, which is 1 upon 1000 into 5 upon 4. So Fr would be 0.00875. The work done by air resistance is equal to force into displacement into cos theta. So this theta at this time, because the force is acting upward and the displacement is in the opposite direction, so the angle in this case is 180 degree. So the value of cos 180 degree is minus 1. Substitute all the values, so it would be 0.00875 into 1000, which is 1 kilometer, into minus 1. So when you solve it, it would be minus 8.75 joule. The work done by the air resistance. Now let's move to the next question. Force F on the particle moving on a straight line, varies with the distance as shown in this figure. The work done on the particle during this displacement of 12 meter is. So in this case, there is a graph between force and distance, and we have to find the work done. So work done is equal to F into D, or I can write F into the change in the displacement, and when we integrate it from x1 to x2, we get the work. So work is equal to area under the graph, force and displacement. Force on y-axis and the displacement in x-axis. So the total work in this case would be equal to, starting from 0 till 12, 0 to 12 meter displacement, or I can write from 0 to 3 meter displacement, 3 to 7 displacement, plus 7 to 12 meter displacement. So from 0 to 3, The force is 0, that's why the area would be 0. From 3 to 7, the force acting on the body is 2 Newton. So this is the area, which is 4 into 2, plus this is the area for 7 to 12. So it would be half into 5 into 2. This is a triangle area, and when you solve it, it would be 8 plus 5, which is equal to 13 joule. This is the work done in this case. D is the correct option. If you have any doubt regarding the video, or you want any mentoring or tutoring from me, you can email me on forcetra.physicss@gmail.com, or you can scan this to DM me directly.